We are going to explain how a flyback converter is working. This is the circuit of the flyback. If we on this transistor, a current is passing through it. That is shown here. The current is passing through it, and the value of the current is given by the voltage applied divided by the inductance. If we assume the inductance as 100 microhenry and the voltage is 10 volts and the on time we taken as 10 microsecond, then if we calculate, we will get here the primary voltage is 10 volt and the inductor value 100 microhenry and the on time is 10 microsecond. Then we will get the peak value as 1 ampere. So it will reach 1 ampere in 10 microsecond. And this is the voltage across the inductor. As the applied voltage is 10 volt, when a current is passing through it, it also produces a EMF that is also equal to the input voltage, that is 10 volt. So the input voltage is 10 volt when the transistor is on. As this is a flyback converter, this is not a transformer, this is a inductor called coupled inductor. Now when the current is going through it like this, in 10 microsecond the current will reach in 1 ampere. So when current is going through this coil, the coil will create a flux that is producing the counter EMF, and the flux is given by the primary voltage divided by number of turns. As we know that the voltage across the induced EMF is equal to number of turns into change of flux. From this equation we can find out the flux. The flux will be given by voltage divided by number of turns into the time it is on. Voltage is 10 volt, input voltage is 10 volt, and the number of turns we assumed as 10. If you take this number of turns as 10 into 10 microsecond, 10 micro web per meter square, this much of flux will be produced by, this is shown here. Now when this transistor is on, this diode is for reverse biased. The voltage across this diode will be given by this voltage, the voltage across the capacitor, and the voltage across the inductor. The voltage across the inductor is given by, if this is Vin 10 volt, 10 volt into number Vin, 10 volt into N. Here the ratio is, this is 10, the number of turns here is 10 and this is 5. So the ratio is 1 by half, 1 by 2. So 1 by 2 of the voltage will be across this when this is on. So when this is 10 volt, 1 by 2 of 10 volt means 5 volt will be at this point. So the voltage at this point is 5 volts. And this capacitor has also 5 volt. So the total voltage across this will be 10 volt minus 10 volts. So this is shown here. V0 means the voltage across this capacitor. This V in into N means V in means 10 volt into half. 10 volt into half is 5 volt. 5 plus 5, 10 volt will be across this diode. So the voltage will be 10 volt. As this is the reverse bias, there will be no current through this diode. But at the same time, during this time, the capacitor is discharging. The capacitor is discharging through the load. This is given by I0. The value of the current is equal to the output current. What the output want, it will supply by the capacitor. We said all the things that are happen when this transistor is on. Now when this transistor is off, there is 10 microweber per meter square flux is there inside. So this generated due to the flow of electrons. So the magnetic field does not, this flux does not want to change immediately, does not want to change to zero immediately. So what it do, it will reverse the polarity. Reverse the polarity means earlier this side is plus and this side is minus. Now this side become minus and this side become plus. And also this polarity will be reversed also. This will now become plus and this will become minus. Why the flux is doing that? The flux want to maintain the energy or maintain the magnetic field same. So the only way to maintain the magnetic field is to move the electrons. Now this path is closed, so the magnetic field tries to move the electrons through this path. So it reverses the polarity of this, and now current flows through this diode to the output and try to maintain the magnetic field. Now there is no energy is coming from the input. The stored energy is released. So the magnetic flux began to decrease, and this is given by Vs by Ns, the output voltage divided by number of turns. The primary has 10 number of coils, and if we wound 5 coils in the secondary, and this is 100 microampere, then if this would be not 50 microampere, half of that, not like that, then how will calculate the inductance of the secondary? That is given by this equation, that is Ls is equal to secondary inductance is equal to N square into primary inductance. N square means the ratio is 1 by 2. Here 10 turns, here 10 turns are here 5 turns are here. So 5 by 10 is 1 by 2. 1 by 2 square into 100 primary inductance. 25 microhenry. The inductance seen by the flux is only 25 microhenry. The inductance is 25 microhenry. The current will be given by the output voltage is as we calculated as 5 volts. Vs output voltage, secondary voltage divided by N square L. N square L means if we calculate that V0 by Ls secondary inductance into the time the switch is off. This is the off time. So the secondary voltage is 5 volts, and as we calculated the inductance is 20, now 1/4 of the primary, that is 25 microhenry into the time period is 10 microsecond. So the current will be 2 ampere. So the peak current will be 2 ampere. So it is not directly, if it is 100 milliampere and number of turns is half, then we cannot say that the inductance is half of this. Secondary inductance is equal to N square into Lp. As the number of turns is half, current has to be double in order to produce the same flux. Now during the off time, what is the voltage across this? The voltage across this inductor. The voltage across this inductor will be given by output voltage. Output voltage is 5 volt divided by N. N means 1 by 2. When this we put V0 divided by 1 by 2, the 2 will be go to the top. So 10 volts. The voltage at this point will be 10 volt. This voltage will be 10 volt. This voltage will be 5 volts. Now during the time there will be no current through this transistor or the inductor, and this is the secondary current. During the time this current has two portions. One portion is going to the capacitor and another portion is going to the load. This average portion is the portion that is going to the load, and the ripple portion is going to this ripple portion is charging this capacitor. From any of these we can calculate the value of the output capacitor also. If we calculate what is the voltage across this diode, as we said earlier that when it is reverse biased, the voltage across this diode will be this voltage V0 5 volts plus the reflected voltage 10 volt into 1 by 2 5 plus 5 10. So this has to be 10 volts. During the off time, what is the rating of this transistor? This transistor has this 10 volts plus this 10 volt. 20 volt is the rating of this transistor. When this is running, the voltage across this will be minus here and plus here. This is also minus and plus. Minus plus minus plus means 20 to 10 plus 10, 20 volt it has to withstand. This voltage rating is 5 plus 5, 10 volts. Now how we can calculate the value of the capacitor? If the current through the I0 if we consider as 1 ampere, the current, the load wanted is 1 ampere. So this is the current wanted, and it is for only 10 microseconds. So only 10 microsecond into 10 microsecond, and the voltage variation we want is only 100 times of 5 volts. That means 0.05. That means 0.05. Then it would be 200 microhenry. This is the value of this capacitor, and the rating of the diode is 10 volts, more than 10 volts. So if the rating is 10 volts, we will put 20 volts diode, and if this rating is 20 volt, we will put 30 or 40 peak inverse voltage withstanding transistors. So this is how a flyback circuit is working.